Chapter 4, Integration, 4.1, Antiderivatives, and Indefinite Integration. Just when you got the derivative down, we're going to turn it on its head here. Okay, if the derivative of x cubed is 3x squared, then the antiderivative of 3x squared is x cubed. Anti, opposite, inverse, against the derivative. Anything that you need to associate with this. So I'll be repeatedly asking you this question. What function has a derivative, in this case, of 3x squared? Okay, what function has a derivative of 3x squared? The answer to that question is the antiderivative. So in this chapter, beginning with this lesson, we start with the derivative and determine the function that has that behavior. A function capital F is an antiderivative of lowercase f if big F prime of x is equal to f of x for all x. Okay. So if the derivative of a function is 2x, what function gives me a derivative of 2x? X squared. So what do we say? 2x, x squared is the antiderivative of 2x. 2x was the derivative, that's where we started. What function has a derivative of 2x? X squared. If the derivative is negative 3, what's the antiderivative? Negative 3x. Why? Because the derivative of negative 3x is negative 3. Wait for it. If the derivative is cosine of x, what's the antiderivative? Sine x. Because the derivative of the sine function is the cosine function. Okay, so why do we need the antiderivative? A differential equation involves x, y, and the derivative of y. So differential, this is what we just spent the past 2 chapters on, being able to find a derivative. So dy dx is equal to 4x, y prime is equal to x cubed plus 1. These are all examples of differential equations. They all are derivative functions. So again, what does the antiderivative do? Antidifferentiation is what we can refer to as indefinite integration. What does this process do? This process, antidifferentiation, solves differential equations. So you'll be given the derivative and you want to find the function that has that given derivative. Alright, so take a minute here. The antiderivative is known as the indefinite integral. Antidifferentiation is just the process of finding the antiderivative. So starting at the derivative and finding the function. Now let's pick apart what this looks like. This is the integral, and the integral is an exaggerated S. You'll see me use that often. This is referred to as the integrand. Dx there, that's called your variable of integration. what you're integrating with respect to has to match what the derivative variable is. So it just tells you what you're integrating with respect to. Big F of x, that's your antiderivative. And this uppercase C, that's your constant of integration. And that's required for the indefinite integral. Alright, so what does this entire thing do? This is what we call the general solution. That's spelled incorrectly. The general solution to any differential equation dy dx. If you find an antiderivative, you can always check your answer by finding the derivative. Alright, so this would be our general solution, uppercase f of x plus c. What's the derivative of this? Big F prime of x plus 0. The derivative of a constant is 0. And then by definition of antiderivative, what's big F prime of x equal to? Little f of x. So in words, the derivative of the antiderivative, it better equal the original function that we started with. All right, what's the integrand? That's what's inside the integral. Okay, so that's what the integrand is. All right, let's look at some examples. Oh, rules first. The integral of 0 is c. How can you check an antiderivative? By taking the derivative. What's the derivative of any constant? 0. The integral of a, so k is any real number. The integral of just a constant is that constant times whatever variable we're integrating with respect to, plus c. You'll see that all of our antiderivatives have a plus c. Why is this true? Derivative of k times x is k. Derivative of c is 0. So where's the k? It's the original integrand. Look at 0. It's the original integrand. So after you take the derivative, it's a bit of a catch-22. You can always see if your work is correct by taking the derivative. Again, k is a constant. When you're evaluating an integral where you have a constant times a function, you can just bring that out front of the integral, do your business, and then just multiply the answer by that variable. When you're adding and subtracting two functions, then you can just add and subtract their individual integrals. Now there's a whole list on page 250 in your book that I would suggest maybe you print out from the CD. And that just compares the derivative rules with the integral rules. Okay, evaluate each integral. Check your answer. So the integral of 3 d theta. What does this mean? Theta is the variable in my answer. Okay, what function has a derivative of 3 theta, and then I need the plus c because it's the general solution. And we'll talk about particular solutions in class and what the difference is. So how can I check my answer? The derivative of 3 theta plus c is 3. 3 is my original integrand. I'm good. What's the integral of ds? Well, this is really the integral of 1 ds. So what's the integral of 1? Just s plus c. Check your work. The derivative with respect to s of s plus some constant would just be 1. And that, again, is our original integrand. All right, power rule lives. If the derivative of x to the n power is n times x to the n minus 1, right, we brought the exponent down and then subtracted 1 from the original. Then the power rule for integrals, add 1 to the exponent and then divide by the new exponent. Always adding our plus c, and this rule is true everywhere except where n equals -1. Okay, and why is that? if we added 1 to the original exponent and then divided by that value, we'd be attempting to divide by 0. Okay, so the power rule for integrals works for every exponent except -1. All right, let's look at some examples. What's the integral of x squared dx? By the power rule, add 1 to the exponent, divide by the new exponent, plus our constant of integration, plus c. Integral of the cube root of x. So like when we learned the power rule with the derivative, rewrite it so it's in the form x raised to some power. Add 1 to the exponent and divide by the new exponent. Dividing by 4/3 is the same as multiplying by 3/4. 3/4 x to the 4/3 plus the c for the constant of integration. Now I say to check your answer. Check your answer using the derivative. What's the derivative of x cubed over 3 plus c? That would just be x squared. That's my original integrand, so I know my antiderivative is correct. What's the derivative of 3/4 x to the 4/3? Okay, using the power rule for derivatives, multiply by the original exponent, subtract 1, they cancel, and I'm left with the cube root of x. So you can check every antiderivative by using the derivative. Okay, let's look at some rules. 4x to the 5th dx. So you have a rule that says you can bring the coefficient out front because that's not affected by the power rule. The power rule says add 1 to the original, then divide by the new exponent. So 2/3 x to the 6th plus c. Check the answer. 2/3 times 6, x to the 5th power, 4x to the 5th, and that's my original. Oh, did I not leave? Okay, I didn't leave enough room. All right, trig. So this is what I'll leave you with. For your homework, complete each trig integral. As you attempt to complete these, ask yourself the question, what trig function has this integrand as its derivative? So the antiderivative of the sine. What function has a derivative of sine? Well, if you think it to be cosine of x, the derivative of cosine is negative sine, so you just have to make the antiderivative negative cosine. And then the plus c, because you need a plus c every time you integrate. Okay, so enjoy this little assignment. This will be due for, let's see, mods 2 and 7 and mod 1. This will be due on Tuesday, the 11th. Enjoy your weekend.